Okay, this screencast is in response to the problem that reads a rhombus is inscribed inside a rectangle, W meters wide, perimeter of 44, or whatever your problem says. Each vertex of the rhombus is a midpoint of a side of the rectangle. Express the area of the rhombus as a function of the rectangle's width. Okay, so here's kind of what I'm thinking when I read that problem. We've got our rectangle, which looks about like that. And then we've got our rhombus that's inscribed inside the rectangle, which with each vertex, which of course they drew the diagram for us, but I just want to draw my own here just for illustration. And so that's really what we're given in the problem. We're told also that the perimeter, the length of all of the sides of this rectangle added up together, is equal to 44. And then of course we have to express the area of the rhombus as a function of the rectangle's width. Okay. So we know that the rectangle's width right here is W. That's all they tell us. They don't tell us what number it's equal to, but they just tell us it's W. All right, a couple of formulas we need here. First of all, the perimeter of a rectangle is going to be 2 times the width plus 2 times the length. And then the area of a rhombus. Now that is going to be what's called the product of the diagonals divided by 2. Okay, so what they're saying is that first of all, they give us somewhere in there that the diagonals are capital D going up and down, and then going side to side, the other diagonal is lowercase d. Okay, those are our 2 diagonals. Now, the lowercase d is a little bit easier to deal with. We can see just by looking at the image here that the lowercase d, that longer diagonal, is equal to w. So there's half the problem right there. And by the way, the area of the rhombus is supposed to be equal to capital D times lowercase d divided by 2. And we've got lowercase d accounted for, it's w. The question is, what is capital D equal to? Here's how we should approach this problem. The perimeter is 44. And remember, the perimeter is equal to 2w plus 2l, right? So 44 is really equal to 2w plus 2l. Now, it's pretty clear that capital D is equal to L, but whenever we write the area of the rhombus, we can't have any L's in there. Whenever we write the formula that's going to be our answer, we need to have nothing but W's. So in other words, what they're trying to say is that we need to write L in terms of W. Here's what you'll do on this problem. First of all, I want to get those 2's out of there. So what I can do is actually divide both sides of my equation by 2. In doing that, I'm going to get 22 is equal to W, because these 2's cancel, plus L. That really helps, because now I can actually solve this for L by subtracting W from both sides and get 22 minus W is equal to L. So I know that the area of the rhombus is going to be equal to the diagonals. And we already know that lowercase d is equal to W. So we know it's capital D times W over 2. And all I'm doing there is just replacing the lowercase d with W. The capital D is going to be equal to the length. But we know that the length, after we solve this, is equal to 22 minus W. So really what we have for our answer, we would be thinking of it as length times width over 2. But since they said we had to express it in terms of W, we're going to replace L with this part right here. Area is going to be 22 minus W times W divided by 2. And that's what the answer for that problem should be. Okay, that's one of the trickier problems on the review, and it really kind of requires you to know what the area of a rhombus is. So, and there will be one like that on the test, so be sure and be aware of that fact. The area of a rhombus is the product of the diagonals, the long diagonal times the short diagonal divided by 2. this right here is our area of the rhombus formula. All right, any other questions, just shoot me an email.